So this is a pH curve, and they always have this kind of S shape to them. We need to be able to explain why they have that shape. Before we do that, let's set some labels to this. So this region here, these pH numbers here, this is the acidic region. And if you remember, acidic because the amount of hydrogen ions will be greater than the amount of hydroxide ions. We then have this region of the graph where here it is high pH values and this is an alkali, and in this region the concentration of hydroxide ions is greater than the concentration of hydrogen ions. In the middle, you notice we've got a little gap in there. This is pH 7, and if you remember here, this is neutral, and when it's neutral, the concentration of hydroxide ions is equal to the concentration of hydrogen ions. So, at the beginning, we only have acid present, which means that we have H plus ions. As the reaction goes on, we're adding more and more hydroxide ions to the reaction. Now, if you remember, H plus ions react with hydroxide ions to form water, and when they do that, it forms a neutral solution. So as we go this way along the curve, we're adding more hydroxide ions. Therefore, the concentration of H plus, let's put that on there, the concentration of H plus is decreasing as they react with the hydroxide ions. We then get to this point, and I'm going to do a little dotted line across this point here, and at this point, this is where our H plus ions are equal to the OH minus ions, and that's when the solutions become neutral pH 7. If we then carry on beyond this, we're going now into our alkali region on the graph, and this is because there are now an excess of hydroxide ions, and that's because we're adding more OH minus ions, and therefore in that region the OH minus ions are more abundant than the H plus, and we have pH values that are very high. Hopefully that helps to explain the shape of the graph, and every pH curve will have a similar shape and for the reasons we've outlined in this response.